Hello again. In this example, we're going to work on a double integral. So what we are given is 2 to 0 for the first integral, 2x to x squared for the second integral. We need to integrate 4x plus 2, first with respect to y, which means these are y equals, and then with respect to x, which means those outer bounds are x equals. So we're going to look at switching or reversing the order of integration. So instead of having it dx or dy dx, to make it look like dx dy and see if that makes it easier to solve. So what we're doing here is we're thinking about what these bounds mean. So since dy is my first variable with which I'm integrating with respect to, these are both y equals. So I'm going to come over here and I'm going to draw my region, R. You can call it whatever you want. We just generally call it R in the notes. We have y equals 2x. So y equals 2x is a line with a slope of 2 going through the origin. And then we also have y equals x squared. Y equals x squared is a parabola opening up. And so what we notice is that these two values are intersecting at x equals 0. And this point of intersection here, that would be x equals 2. And you see that 0 and 2 showing up for my outer integral, which is dx. So if we were to reverse the order of integration, that means we would want our bounds to have x first, which means we need both of these equations in terms of x. So y being equal to x squared, that's the same as x being equal to plus or minus the square root of y. And in this situation, because it's only the right half of the parabola that we are considering, we don't need that plus or minus. We'll just say x equals y. And the other equation, if we rewrote that in terms of x, that would be x equals y over 2, or 1/2 y. So what does that mean my vertical bounds, my y bounds would be? We'd be going from 0, and this output value, if I were to plug 2 into either of these equations, 2 squared, 2 times 2, we get 4. So if we want to consider finding the volume between this region and my surface, and we want to change those bounds, we need dx first. So here, the way this is written, we have an upper bound, which is my 2x, that's the function above, and then x squared, that is my function on the bottom. So setting this up differently, we would have y on the outside here. So my y is going to go, we've got y equals 0 and y equals 4. So my upper and lower bounds in terms of y, we're going from 0 to 4. So then what are my left and right bounds in terms of x, x in terms of y, I should say. So my left, when we think about this extending out, we would first, my lower bound in this situation would be y over 2, and my upper bound would be square root of y. So we have here x equals y over 2, and then x equals square root of y. 4x plus 2, and that gives us dx dy. All right, so we can do this, set it up this way or that way. Both of them are going to give us the same answer, but what we want to notice is our bounds change. So what we're going to do, let's go ahead and evaluate this, just make sure we have a little bit extra practice evaluating these integrals. So integrate first with respect to x. That's going to give me y equals 0, y equals 4. Integrating this, that is x squared over 2, or 2x squared plus 2x. And then I've got x equals the square root of y, x equals y over 2. We still will need to integrate with respect to y. And there's really no way around this. We always are going to have to plug that value in and simplify this little algebraic expression. So we've got 2 square root of y squared. That's just going to be 2y plus 2 square root of y. And then we've got minus 2 y over 2 squared, which is going to be y squared over 4. And of course, we're subtracting all of this, so I've got plus 2 times y over 2. So distributing that negative, this will be minus y. Here I'm going to have y squared over 2. This. Now all my variables in the integrand are y. We're integrating with respect to y, and once we're done, we're going to plug in 4 and 0. So integrating 2y, I get y squared. Integrating 2y to the 1/2, this is 2y to the 1/2, I end up with 4/3 y to the 3/2. I get minus 1/6 y cubed, and then minus 1/2 y squared. We need to evaluate that from 4 to 0. Obviously, when I take that 0, plug it into all these terms, it's going to 0 out. So I just need to plug in my 4. And 4 squared plus 4/3 times 4 to the 3/2 minus 4 cubed over 6 minus 4 squared over 2. That's going to simplify and give me 8. So 8 is the value I would get when I calculate this integral. And just to be clear, we can calculate the first way and it will work out just as fine as well. It's just there are no x's here, so it might be a little bit more complicated when we get to this algebraic step where we plug all of that in. But really, they both work. It's just a matter of being able to understand the bounds. So that's why I think this is a good example for us to look at. And if you have time, I encourage you to work through it this way and see that you will also get 8 as that value. Good luck. Ask me any questions. Send me emails. I'm here. I'm waiting. I just want to help.